Is it a first class after the seventh initial demo?
Yes, yes, yes. So that was actually the introduction that we are going to do in this whole course. So
Mhm.
basically, today we are starting. So as you all guys know, or if any one of you just joined today, so this is a batch. We will start like this. Like we will be learning CCNA plus Cisco firewalls, and in firewall we will be doing that ASA and FTD. Okay. So now this is the first day where we are starting our this batch from CCNA. Okay. So this is something which we have already discussed about like what exactly we're going to cover in this course. I'm not wasting much more time on that. So now we are straight away jump to CCNA. Okay. So just forget about CCNA. Today we will be learning few terms that is being there while you learn about networking. As I said, while you learn about networking, so let's first talk about networking only. Okay, guys. So the simple thing, guys, what is network? So what comes in your mind when you heard this term network or networking, right? So what exactly things that comes to your mind? So if I state it in a very guys, if you can mute yourself, that will be great. Okay. So, what is networking? So, basically, network is a combination when we have multiple of devices connecting together. Mohammed, if you can just mute yourself. Okay, thank you so much. So, guys, as I'm saying, networking is what? So, network is what? Network is something when multiple devices, I'm not talking about network devices, I'm talking about when multiple devices connected together and providing us some kind of services. If I'm talking about services, so it is basically sharing some files, accessing the internet, and the way we are connected today. I'm at my home, you guys at your home, we are connected via an app which is Zoom. So this is an example of networking, right? So in real time, what exactly we are doing? We are in a frame of network while which I am delivering a service for you guys. So this is a simple example where we talk about what is network. So you can just relate this, right? You just accessing the Zoom app, jump onto this class, having your class, like that. So this is something whenever multiple devices connecting together in a network to provide you some kind of service. Okay, so it is basically the practice of connecting computers and other devices together so that guys they can communicate like we are doing and share resources. So suppose I'll just share you any file over here. So you all can access that file, right? So sharing a resources or communicating like we are doing. So this is a network. So if I'm just giving a little example to just correlate this term, like just imagine it's a group of friends. Basically, what they are doing, just chatting, sharing their things with each other. So we are doing a communication by which we will be sharing the file, we will be communicating with each other. So this is just an example of networking. And how it in technical terms I can relate that to you is networking allow multiple devices like computers, smartphones, and printers to connect with each other and exchange information. So in a simple language, this could be a sending emails, sharing files, or accessing the internet, right? So let's just write down the definition in a simple technical language. I'm not going into some of the fancy terms over here. So just I'm just writing down that thing in a simple technical way. So it is, just bear with my writing, guys. I try my best to write down in a good handwriting, but it is what it is. So as I stated, interconnection of two or more device is called as a network. Okay. Any confusion in this, guys, in this simple definition or the term or the way I explained you? Is there any doubt? What is network? What is networking? No doubts? Okay. Another simple definition of network. So, as I stated, the communication between two or more interconnected devices. So, guys, here comes the thing. This is one PC. This is another PC. PC1, PC2. So, are you guys considering this as a networking? Tell me, guys. Are you guys, as per my definitions, are you guys seeing this as a network? Anyone
Yes.
of you? Okay, it is. So, if I ask you why so,
The reason behind this is both can able to communicate with each other.
yes, and they are connected. So, see, I'm in a simple language. This is just internet. Okay, just consider it as a internet. So they are connecting via medium. So in internet, there must be multiple of devices. And what your way or what your main aim to connect to PC2? To share files, right? Now let's again go to another thing. This is you at your home. This is PC1. You connected to your, okay. This is nothing but your Google server. So you at your home, this is your PC. You just type www.google.com. So, guys, is this another example of networking? Guys, I'm not looking at the chat, so you have to speak whether yes or no.
Yes,
Yes.
It is. So, any one of you can just give me why. Just tell me the why.
because because the Google
Mhm.
um what you call server is sharing the resources with me.
So in here we are accessing a server via internet. So this is another example of networking, right? Because we are connected to my home router, and that router is connected to their dedicated ISP, and that ISP is having some connection with the Google server where we are situated, right? So this is another example of networking. So this is, I'm just writing it as accessing internet. Okay, guys. So this is how you can simply define what is networking. Okay, and here I just want to add one more thing. So yes, now we know. Okay, this is networking. This is the network. So now, if I talk about what is the goal behind it, so let me talk about the goal. Goal of networking. So guys, in first example, what was your goal? So guys, in first example, what was your goal? You were sharing some file with PC2 and PC1 is sharing some file with PC2. This is something vice versa, right? Agree with me?
Yes.
Yes, so far so good. Yep.
Yep. So sharing a file is our goal of networking. So this is just a goal. You can just type what's the need or why do we require network? So you can just consider it like that. So in this example, we are sharing file. And now if I jump to the other one, this is one what? What we are doing? Accessing the internet, right? Okay. And now I'm giving an example. Most of you will love this example. Let me just write it down first. Got my point? Playing online games, guys. I don't know how many of you interested in playing games online or playing multiplayer games, playing with your friend online. I don't know about that, but this is something you can relate, right? Whenever you playing any of the game, whether it is BGMI, whether it is FIFA, whether it is cricket, and you playing online with your friend, or with multiple players. So this is an example of networking. Okay, so you can connect with friend around the world. Okay, and via accessing the internet, guys, so all device in a home can connect to internet through a single router. This is that example for you. This is your router. This is your PC, or sometimes you have another laptop, and sometimes you connected via smartphone. Okay, and first one is sharing files. So you can share documents with coworkers easily. So this is, you can relate if you're working in your company, you access the servers, or you access some of the servers where you uploaded some file. Today, if I can talk about, which is OneDrive. If you're working, your company must be related with OneDrive where your file is stored. So on the daily basis, you're accessing the file from OneDrive. That is an example of sharing file, right, guys? So, guys, any doubt in this simple networking term? Or you can say, let me just make it a slash, which is network. Yep. Any doubt, guys? Go ahead. Let me just see the chats. Okay. So you can call me Mohammed. You can call me Arun. Okay, guys. So now we are done with network. Now you and all of us know. Okay, this is networking. If we are doing, if we are accessing the internet, if we are sharing some file, if we are accessing the Google, or if we are playing a game, and we are just having a class. So this is networking, right? This is networking. How it is done, why it is done, just forget about. But now we know this is network, and what are the reason behind, or what are the goals we achieved via networking. So that is, if we want to share any file, we require network. If we want to access, if we want to access the internet, we require network. And if we are playing online games, attending this online class, this is even example of network. Okay. So now let me just rub it. So guys, if you are making your notes, that's really good. But if you are making your notes by watching recording, that is also good. But if you are making an expectation from me, I'll give you any of the document or something, that is the wrong thing. I won't be doing that. So in my class, you just want to write it down, all the notes by your own. That's it. Okay, let me see one of the chat. No doubt. Okay. Okay, thank you, Gagan. Okay, guys. So after completing one of the topic, I would just like to know about you guys. What's your expectations? What you are currently doing? Okay. So now, guys, let's listen to another terms, which is types of network. Okay, so now we know, okay, this is network, this is this, what is the requirement of network. But now, how many types of networks we have? So I'm not jumping straight to any of the type, right? I'm not straight away jump. So first one is LAN, local area network. Okay, guys, start one by one. Give me what you understand about this LAN term, local area network. Come on. Any one of you, just give me layman example, no need to go with definition. Just explain me what you exactly understand by this term. Go ahead. Any one of you?
My
To
home.
provide the yeah, to provide the physical connectivity inside the area,
Okay,
inside
so
the
by you saying
same
area,
network.
so is that a underdefined area or it is not defined area? That is a catchy term in land. Okay, Venkatesh, thank you. Any other wants to?
So a network that connect device in a single location, like home, offices, buildings.
Okay, okay, thank you, Gagan. Okay, guys. So I think most of you know about it, but I'm here to explain each and everything. So LAN is a network, guys, that connects device within. See, I won't be saying small area. I'm saying small geographic area. So for example of LAN is a home. I am connected to internet at my home via my router. This is an example of LAN. You are in a small office. See, okay. So in there, only 2 or 3 persons, or maybe maximum 5 persons are working. So that is an example of LAN. You have internet accessibility in school, right? So this is another example of LAN. Okay. So let me just write down the definition, and after that, we're going to talk about it more. So LAN, how we do it? LAN are used to connect networking devices that are in a very close, very close geographic area. Okay, so if I can go that the example of it, floor of a building, and okay, or within a camp. Okay, guys. So now from home we are accessing the internet. So let me just make a small diagram of it. Let me use this one. This is my switch or hub. PC2, PC3, PC4. This may be switch. This is maybe hub. Okay, guys. So I'm not defining it specific switch or hub. Okay. So now this is an example of LAN where multiple network devices are connected to each other, but that are in very close geographic area. And that area I'm considering uh, floor of my home or maybe my home network, okay, or a campus or anything. Okay, guys. So now So, in a simple language, guys, whenever you heard this LAN term, just replicate this as a your home Wi-Fi network. That's it. Your smartphone is connected to your internet via your Wi-Fi. That is an example of LAN. That's it. Nothing else to worry about. Okay. Now we are talking about LAN. So, what are the every- everything is fine with you, Pooja?
Yes, sir.
Okay, no issue. I thought you take too much seriousness about LAN, but no issue. Features. Okay, guys. So let's talk about the features. Why we are discussing that? Okay. So, guys, if the area is small, okay, the area is way too small for LAN. So, what do you think? What do you expect when you connect to your internet? What do you expect the most? Tell me. What's your expectation with from your internet? Tell me. Guys, tell me what's your expectation from your home network?
To get a internet source.
Speed.
Sorry, someone said speed, right?
Yes, correct.
Yes. So why speed? Why specified to speed only? Tell me.
By for web surfing and sharing the data.
But that is, yeah, I know this is a usage, right? This is a usage. That is why you're using internet. But to get your goal, what internet provide you? Internet providing you, so you judge internet on the basis of speed, aren't you? Guys, you're not judging your internet by speed. You're doing so, right?
Yes.
Yes.
So that
Yes,
is
sir.
the
Yes, sir.
feature. Speed. So as I can say, as you can see, it is for very close geographical area. So the main feature is it will got a great speed to serve you guys. Okay, so this is a benefit for LAN. Okay, now let's talk about one more thing, which is you must be agree with me. This is limited range. Agree with me on this, guys, because see, we are stated that LAN is used to connect networking device that are in very close geographical area. So for that, we have limited range only because it covers a small area, usually within 100 meter, guys. And mark my word, within 100 meter. Because why I'm saying within 100 meter, I'll prove that. How I prove that? Because there is something related to this that we are talking about maybe today or tomorrow. But just mark my term, limited to 100 meters. Okay. Now, what are the common uses of my LAN? So we basically just serving internet, right? So let me just write it down. Common use. The common use is sharing your files, gaming, and accessing the internet. Well, accessing the internet is not exactly example over here because in WAN, LAN, maybe accessing internet is just example for networking. But for LAN, you can just connect your sometime your in your offices printers are connected via LAN, so you can just setting your office desk and simply control P and your printer just showcase the print command, right? So that is LAN, guys. In a simple language, the most simplest language where I can just explain you guys LAN. So is there any doubt in LAN part, guys? No doubt. Okay. So guys, if you can speak, that will be great because I won't be able to do again and again see the chat. Okay, just say yes or no in a simple thing. Okay, so now LAN is done. Now let's talk about another term, which is any guesses, guys? I hope everybody knows about that.
WAN,
Yeah, it is. And how WAN stands for?
wider area network.
Yes, it is. Okay, so now our topic is WAN, which is wide area network. So now, if I stated that, guys, so WAN connects multiple LAN over a large geographical area. So now we just talked about LAN. LAN is a small network. So we are giving an example of LAN is as a wow, as our home network. But what if I just tell you a small network? So we just talk about our home network, but just take an example. Our home network is just a company, right? Just a company. So let me just make a diagram of it. So this is a small. This is another small network I'm talking about. So just answer me, guys. So you guys consider this as a LAN network? Yes, guys. Do you guys consider this as a LAN network?
Yes,
Why so?
they have defined boundaries.
Exactly. This is my internet. Okay. Now, here another. Similarly, like that, this is another LAN network, right? Okay. So if I'll go to, this is somewhere in Delhi. This is somewhere in. So if this LAN network, or just consider this is your office. So in your office, one branch is in Delhi and other branch is in Punjab. And see, in offices, I know I'm just assuming most of you are working. So you have a branch office where you have a headquarters. So you must have something there in your headquarter, any of the file services, file sharing thing, or any of the server from where you can download the files, accessing any of the things, right? Accessing any URL that is hosted over there, any server that is hosted onto your headquarter, you do access that, right? So that is an example. When is something in a simple language, it is connecting one or more LAN network together. Is it clear, guys? Like, am I making sense to it?
100%.
Okay. Any doubt, guys? Any doubt? Let me help of router. So I'm not see Venkitesh. Why I'm not saying routers, switches, term. I don't want you guys to be into that. I am not talking about the devices by which network is created. We are currently talked about hypothetical. right? Just the hypothetical terms. That what is LAN, what is WAN. So WAN is a combination by which two LAN networks communicate with each other. That is what WAN is. Is it correct?
Yes, sir.
Okay. Yes, someone is saying something. So
Sir,
WAN.
hello. So I have one doubt, sir.
Yeah, sure,
Uh,
sure.
Sir, actually, nearby location, both plants in nearby locations, they're nearly over 4 5 kilometers. We are connecting through RF in both plants. It comes under LAN or WAN, sir.
Sorry. Just repeat it again. Repeat it once again.
Sir, actually, plant A, plant B, both plants is there.
Mhm.
Hello. Sir, both plants is there, sir. Nearby location, 4 to 5 kilometers. The both plants are connected with RF.
Uh-huh.
So is that comes under LAN or WAN, sir? So that's even internet connection is down also, it will work through RF.
Through RF. So okay.
RF.
So
It
in
comes
LAN,
under LAN or WAN.
okay. So in LAN, I just told you to mark one term. What was that term? Within a range
Yeah.
of 100 meters.
Yes, sir. Yes.
So the example you're talking about that comes under man, which is our next topic. LAN, WAN, and then man. All the way logically, I would go like LAN, WAN, and man, but I just want to cover the WAN term first. Because in
Okay, sir.
real time example, you will be working mostly on LAN and WAN only. Man is something in between LAN and WAN, but it is something bigger than LAN. So the example you're talking about that comes under man thing. So we'll talk about that. We'll talk about that just after WAN.
Okay, sir. Okay, okay.
Okay, guys. So as I'm writing, WAN connects multiple LANs over a large geographical area, and it's often use what? Often using telecommunication lines. So I'm talking about these leased lines. Okay. Now let's come to, and guys, one more example. So the internet itself is the largest WAN connecting millions of networks globally. Okay. So now let me just talk about features. Okay, guys. So one of the good features of WAN, as per you, what is this? You're getting connectivity from one branch to another branch over a large geographical area. So what will be the first feature that is beneficial for you? Tell me.
Communicate without any interruption.
But see, yes, it is a benefit. But what you exactly get, so the thing you talk about that you get in LAN also, but in WAN, what is the difference?
Global connectivity.
Large geographic area. So that means you get the connectivity within long distance. Agree with me?
Yes.
Okay.
This
Yes, go ahead. Covers large area or areas, even continents also. Okay. And let's talk about, guys, please mute yourself. Please. Suresh, if you can just unmute, mute yourself. Okay, so guys, in LAN, I talked about your home network. So in your home network, what is your expectation from your internet? We already talked about it is speed, right? But in WAN, if I compare the speed with LAN, it's quite slow. I'm not saying WAN is slow. Mark my word, I'm not saying WAN is slow. I'm saying as compared to LAN. And what was the reason, or and what will be the reason behind that? What will be the reason, guys?
Because there are other
Can
users.
you repeat yourself, sir?
Sorry?
Can you repeat yourself? Sir? Can
I'm
you
sorry.
repeat for us, please?
Okay, so I'm saying that when I talk about LAN, I mark my word that it is your home Wi-Fi network. So in your home Wi-Fi network, how you define that you want to use this network or that network via comparing speed, right?
Mhm.
So in LAN network, we jump onto speed thing. Okay, I want higher speed, faster speed. But in WAN, I'm saying that it is a lower speed than LAN. I'm not saying WAN is slow, but if you're comparing your speed with respect to LAN, WAN is pretty slow. Why is so?
There are
Because
many hops involved. Like
yes, many
if a
hops.
part,
Yes,
yeah.
so I'm not jumping into hops term right away because this is something technical. So when I'm just talking about the speed, it's just a difference
So
that in LAN you have a limited area, but in WAN you are
they
connecting
have multiple
your
users.
multiple users and it rely on distance also.
Yeah.
So just in a simple language, don't go hops, don't go about intermediate connectivity, how many devices are connected. Just forget about that because now we are just making our base. I know many of you understand about hops, network devices, but here many of the other students who are very much new about networking. Okay, so that's why I'm not using any technical term yet. So just why the speed is lower, just mark it the term as due to distance because in LAN and WAN, the only difference I'm talking about is the distance only. So we are talking on the basis of distance only. I'm not
Sir,
going to
uh,
hopes or anything.
ask.
Yes, Johnson, you're saying something?
Yes. You said in one we only talk about distance. So because of the distance, it lower the speed. So what about the amount of users? Can we say the amount of users to also lower the speed? Because if you have multiple users sharing the same resources, it's sometimes to lower the speed.
Oh, it is. There are many reasons for lower speed, right? Many reasons. But I'm just till now, till this point, I'm sticking with only distance. And why
Oh,
so? I have already mentioned that because I want to cover this topic from zero to hero, right? So
okay.
yes, multiple users, multiple of network devices connecting in between that. I know, but now I'm just concentrating on those people who are very much new, who just heard this term for the very first time, which is LAN and WAN. So how they distinguish in between LAN and WAN is on the basis of distance, right? So that is the reason why I'm concentrating on this term due to the distance. All the way, guys, I know there are multiple factors of speed that varies in network, but I'm not jumping onto that. All the way, we're going to talk about those terms further in the course, but not today. Okay? Understood,
Okay.
guys?
Yes.
Okay. Okay, guys. So now if I talk about one more feature, So it is, if I go for common uses, so just writing down the common uses. So the example that we just take is connecting branch offices of a company. This is a common uses of WAN. Okay, guys. So, guys, any doubt? You have 2-3 minutes to have a look about it, because now we will be jumping into another type of network, which is MAN, Metropolitan Area Network. Okay. Any doubt, guys, or should I continue? Okay, nothing in chat. So,
No doubt, sir.
okay, I'm good to go. So now, guys, when you talk about MAN, any idea? Anyone can help me with that? Like to start with it? Any one of you? Don't go with the technical terms. Just give me a layman example, or just define me in a simple language, if you can.
Metropolitan covers larger areas geographically.
Okay, so by you saying large area, is that a defined or undefined?
I'm not sure.
Okay, so it's a very simple. It covers larger area than land, but smaller than WAN. Got it?
Yes.
No. Tell me once again.
Yes, yes, I'm doing that. So, guys, for man, I'm just simply saying it covers a larger geographical area than land, but it is smaller than WAN. So, we have taken an example in WAN. What example we have taken? This is a LAN network. This is a LAN network. So now I'm situated in an office that is in Delhi. But in Delhi itself, I'm having multiple of branches. And that branches are relies in between, suppose, 20 kilometers. Then if I want to connect all those land branches, or I can say not forget about land. If I just want to connect all those branches together, I will do it by man. Now, just for you guys to make that thing understand real quick. This is internet, and there we have another site. And in that site, we have bunch of network, or you can say bunch of LAN network. Then this is an example of WAN. What you say, guys? What you say, guys? Is this understood or is this bit confusing for you?
Understood. It's clear.
Anybody, guys? I want answer from each of you, because most of the time people got confused in between LAN and MAN. WAN is what is clear. Understood, guys? Okay, so I'm considering it as a yes. So as I stated, guys, MAN covers a large geographical area than LAN, but it is smaller than WAN. So typically, the example, if I can say, or typically the example I have mentioned over here, it is serving a city or a large campus. So if I can just go for another example, it is a network used by a city to connect government buildings and public sectors. Guys, no issues, right? No doubt. Understood? Understood? Okay. Okay. Great. So let me just rub this real quick and just write down the definition. Guys, after that, you should know what is network and what are the types of network that we have. Okay. So let's go and write down the definition, which is a man covers larger geographical area than land. Let me change the color then. The land, but a smaller than a van. So it's basically serving a city or a large campus. Okay. So the example that I have just given you, let me write down that. For example, guys, network used by a city, okay, to connect government buildings, okay, and public. Okay, so now let's talk about the features, guys. So now if I'm gonna talk about the features, so this is, see, WAN is large range, LAN is small range. So this is what? So if I just want to mention any typical range for it, so it will be okay. And guys, another confusion. See, as per the distance wise, man comes in between LAN and WAN. So what your take on to speed? Tell me, what your take on speed? Tell me, guys, what your take on speed? This is the tricky part, guys. Come on, any one of you, go ahead.
Speed should be normal as we are getting in LAN.
Okay, I just take your opinion beside any one of you just try. This is a typical part because in distance wise it comes in between LAN and WAN, right? Now tell me, because if you know, remember the speed topic, what will be the speed, guys? Come on. Okay, I
It's
think
less
let's
than LAN, more than WAN.
okay. That's a really great take. Any one of you wants to try? Okay, so you are correct. You are correct. So it is faster than WAN, but slower than LAN. Is that clear, guys?
Didn't make sense. You said faster than WAN, slower than LAN.
Yeah.
I see.
Does that make sense to you? Guys, speed is the thing. Is it all good or not? Just tell me. Or should I just go again with it? So guys, let me just repeat it. So LAN is for limited area. So in limited area, we have a speed. We have a higher speed. WAN is for large area. So in WAN, we have the speed which is slower than LAN. But for WAN, that comes in between LAN and WAN. So speed factor must be greater than WAN because we are not covering the distance that will be covered in WAN. Okay, but we are covering a distance more than LAN. So it will be when it comes to speed, it is larger than WAN but slower than LAN. Okay, and if I can go for common use, this is connecting any local government offices or universities. So let me just write it down. Connecting offices.
So in other words, you're saying in a WAN, if I'm getting 250 megabytes per second, so in MAN, metropolitan, I'll be getting faster than that. But
Okay, no. So for LAN, so you saying you giving an example in starting for LAN or WAN? Just tell me.
when you say faster than WAN, but slower than LAN, shouldn't that be opposite? I mean, faster than LAN, but slower than WAN? Because I'm just confused, when you say that, okay, the local area networks, there are a bunch of computers, locally connected, that is LAN. So we have got a bit of extra speed in that. Okay. So in a wide area network, I'm just confused myself now.
No, no issue, no issue. I'm just coming on. This is network one. This is network two. This is network three. Now tell me, guys. Just forget about LAN, MAN, WAN. For network number one, for network number two, and network number three, which will be serving you the high speed internet? All of you.
Home, city, state.
So first I'm
Yeah,
asking, which will be giving you the highest speed?
Home network.
network one. Home network.
And from home, city, state, what do you think which will be the slowest one?
State.
State, right?
Yes.
And city is must be not giving a speed compared to home, but not as slow as state, right? Now just tell me, with respect to LAN, MAN, WAN, which network you're defining? Tell me. Or, I don't want you guys to get confused.
Okay, I got it now. Yeah, thank you very much for explaining.
Is that make sense now, guys?
Yes, sir, it makes sense, sir.
Yes,
All of
sir.
you? All of you?
Yes, sir.
Okay. So this is why I'm saying just try to relate my thing in a real-time example. Do not include switch, router, Wi-Fi. Forget about everything. Just go with the simple example. I'm not considering the fact whenever you're connecting in a state, you have bunch of devices. Whenever you're connecting within the state, you have bunch of devices. Just forget about devices. Here we are talking about type of network. LAN, MAN, WAN. LAN is something limited area. MAN is something it has the area but more than LAN. But as compared to WAN, it is a smaller area. And WAN is something if you want to connect any further state, you can do it by WAN. So by this, the topic of types of networks is finished, guys. Is it, guys? Are you okay with that? Declaring need to finish this topic.
Is this range is
Yes.
defined like 5 to 50 kilometers or it can be more?
So it can be more, but if you talk about the ideal range, okay, so you don't want to extend your networks, or you just want to, going for a WAN network, but you just want to extend your network range regarding WAN. So it is something. So it is depending upon multiple of factors. We're going to talk about that in later on. But today you can just keep in your mind. Okay, we have some ranges that would be not greater than WAN and not comes under LAN. Okay, but for LAN it is minimum 100 meters, right? Sorry, maximum 100 meters.
Okay.
Okay, so guys, any doubt in this, or should we just proceed?
Please proceed. Yes.
Okay. So now, guys, we are done with types of network. Okay. Now the things comes under that. What will be the objects? Okay. Spending according obtained bandwidth. Understood. Okay. Okay. So now let's talk about basic requirements. So now we talked about network, types of network. Now let's dive into another topic, which is basic requirements to form. Okay, so I just write it down wrong way. Basic requirement of network is also correct, but I just want to mention that like that. To form a network, how we can create a network, right? I'm just writing down the terms. You can just LAN card all the way, that stands for network interface card. Media, networking devices. So in this, some bunch of the protocols, IP address can go for. Okay, guys, so these are the basic requirements that we need to have to form a network. Okay, so first of all, this is NIC, which is Network Interface card, or most of you must heard this term is LAN card. Any idea, guys? Any hard guesses? What is LAN card or what is this? No idea? No idea, guys?
Wherever LAN ports are connected in laptop or in monitors.
Yes, this is something in a layman language. Yes, in a layman language, you are correct. You are correct. By which we will be connecting towards network, right? So it is an interface between the computer and the network. Why I'm telling so? Okay, so this term might not, you might not able to understand it today, but in later on you got this term. So this is what it is, something interface between the computer and the network. Okay, so guys, whenever you connecting a LAN from your router to your laptop, you use a cable. What that cable is? Any idea?
Net, a network cable, a LAN cable.
A LAN.
VDM.
Okay, a LAN cable, right?
Yeah.
So just tell me how your computer know about that LAN. Is there must be something installed on your computer, or there must be any hardware thing that is there to understand about LAN, right? To understand that cable.
It's the LAN card, the network interface card, NIC.
Network drivers.
Yes. So and if I just go into deeper dive, it is Ethernet card, right? The RJ45 cable I'm talking about. Okay, so that is something required in order for you guys to connect it to network. Because how you gonna connect to the network? Tell me, how are you gonna connect? By a mode of something where from you see now today's we have a wireless also. Not jump into wireless. We have a separate section for that. I'm just talking about if you have a router. This is your modem. This is your modem. So from this modem, you connect it to your PC. That is where comes that is where a logic comes, which is NIC card interface. Mohammed, if you can just mute yourself. Okay. Just I'm just telling you one technical term over here, which is speed. We talked about speed, right? So in this NIC, which is network interface card, we have a column which is Ethernet. Fast Ethernet. Any one of you knows about the ranges? Any one of you for Ethernet?
Yeah. Ethernet is something around 10 megabytes per second.
Okay. And for fast Ethernet?
Fast is 100 megabits per second.
Yep. And for gigabyte?
1 gigabit to 10. It's gigabits per second.
Yeah.
Or 1000 megabits.
So guys, these are the ranges. So whenever you are having a connectivity via NIC card, if you're using fast Ethernet mode, it will gives you speed up to 10 Mbps. If you are connecting it with a fast Ethernet, it will give you 100 Mbps up to. And for gigabit Ethernet, it is 1000 Mbps. Okay, I'm not jumping into this topic because I know when we talk about NIC card, I'm need to talk about the network devices and showcase you where that NIC card is present. Okay, so we will be doing that when we jump into switches and router. Okay, but just now for connecting or to form a network, we require some basic requirements. So one of them is NIC or LAN card. Okay, and if I jump onto media, so we just talked about media, right? Wired, wireless. Okay, so in media, we have some columns, which is this is guided, unguided, and in guided we have another three, which is this is a type of cables: coaxial, twisted pair, and fiber. Okay, and unguided means infrared and RF. In starting, people ask me about RF. Okay, so this is the media by which your data will be flowing. Okay, so this is something how your data will flow, or on what medium data is flowing. So whenever you connect it to internet, whenever you're connecting to a router from your PC, you connected via a media. So whether it is a coaxial cable, whether it is a twisted pair, whether it is by fiber, that is depending upon multiple factors. But we're going to talk about, so it is basically purpose of media is to transport bits from one machine to another, and there are a form by which you can define that. Okay, I'm not jumping into that, guys. We're going to talk about media, but that is not a important topic. You need to understand it. Just to transport data from one machine to another, we require a media. Media means how they are connected. So in here, we are talking about guided, which is coaxial, twisted pair, and fiber. These are the cables by which you are connecting your device from one to another. And how they understand about this cable, that is because of that NIC card that is present inside your network device. Whenever you put a LAN cable onto your PC, your NIC card got activated because that LAN cable just clipped into that LAN card only. Okay, so we're going to talk about that when we comes on to individual network devices. Now, guys, uh, let's talk about network devices. Although I don't want to cover that today, but let's do it. Let's do it because I think we all are on the same platform now. That you,
Yeah, I have a question here.
yeah, sure, go ahead, Mohammed. Yeah.
Yeah, concerning the guided and unguided. What's
Mm-hmm.
the other name of both? The other
Sorry,
name for the other name for guided.
other name for guided. So it is
Yeah.
something related to your media.
Okay.
So if I talk about guided, it's just simply mention that where we have a physical connectivity in between. There is no cross connection. Okay, when
Okay.
something is directly connected to each other, we are talking it as a guided.
Okay.
Okay,
Yeah.
no issue. When we connected one device to another, we're gonna talk about that. Okay, we're gonna talk about that. Now, guys, let's come to wait. I think we have something on chat. Okay. Now, guys, let's talk about the important thing. Network devices. So here comes the important part. So we have hub, we have switch, we have router, firewalls, and if I just want to take one from wireless, access point. Okay, guys, any one of you just want to jump into what is switch, what is router, you're okay to come upon and have a discussion about it. Any one of you want to tell me about hub? Anyone? Okay.
So how So hub
Yes,
is
sir.
a hub is a kind of a dumb device. It whatever it receive it broadcasts to all the interconnecting devices.
Mhm.
Whereas switch is smart and works on the layer 2. And now I think layer 3 switches is also in the market in with the name of the router. Router provides the L3 capabilities.
Mhm.
Firewall comes between the range of L4 to L7, where it provides the network security. Access points are basically they are providing a kind of Wi-Fi connections uh, which will assisting us to provide the wireless connectivity.
Fair enough. Fair enough. That is good. But you use some of the terms which are very technical. But in layman language, guys, any one of you wants to explain that again? Like just want to add on something, or should I just go?
Hub is, yes, as uh, my friend said, that it's a dumb device. Yeah. Yeah,
Mhm.
please explain into your own words. Thank you.
Okay. So, guys, first of all, yes, hub is a dumb device. But hub, or we will talk it as a repeater. Okay. So if I talk about hub, guys, we use hub to connect multiple devices. Okay. Uh, as I used previously, mentioning that whether it is hub or switch, I don't know. This is my P. This is my P. So to get the connectivity between multiple of devices, we connect those devices via a network device. This is my network device. This is my endpoint, right? This is my endpoint. So it is connected via hub or switch. So when this PC1, this is PC2, PC3, PC4, PC5. So they are connected in a network. And as we just talked about, or we just talked about initially in our class, what are the aim to connect with the network? To maybe doing some file sharing, or maybe to have the accessibility of internet. But in this case, just take an example, simple example. We have five PCs connected to each other via hub. Okay, just forget about switch now. Okay, just forget about switch now. So now my aim is, as a PC1, my aim is to have a connectivity with PC5. Okay, I just want to have a connectivity with PC5. And hub being a network device, they will provide me that connectivity. Okay, they will hub will provide me that connectivity, even switch will. Okay, so now till this point I am staying this till this point. Okay, as uh, two students just said that hub is dumb device. Okay, so just consider this device as a dumb. But mark my word, we can use switch also in the place of hub, but and we can use this vice versa. Like the work that has been done by hub, switch will do the same work, and the work done by switch, we can do the same work by hub also. Agree with me or not? If you're not, you have to. Till this point, you have to agree with me. Although I know in further stages I will be changing this thought, but till this point, guys, I am mentioning that the main aim for me is to connect all the five pieces together in a network. So we can achieve that by switch also and by hub also. Got my point? Yes, Nasir, go ahead.
Isn't that hub that when PCA is trying to communicate with PC B
Mhm.
or C,
Uh-huh.
so but on the same time, if PCB is also trying to communicate with the another PC, so they have to wait for their turn. But as in switch, they can
Hold on, hold,
communicate without
hold on, hold on,
interruption.
hold on, hold on, hold on. I know all those things. I just don't want you guys to straight away jump on. Just forget about waiting, listening, transmitting, receiving. I'm saying that if I'm having five PCs, suppose you are a network architect. I come to you, see, I have a five people and I want a small office network. Listen to my aim. I just want all my employees are connected to each other. And I just want that thing only. So just tell me, should I use hub or switch, or should I use any one of you? Just tell me. Any one of you,
You
right?
you can use both.
I can use both. Agree with me, guys? Agree with
Yes.
me, Nasir?
Yes, 100%. Yep.
Agree,
Okay.
sir.
Okay. So now, guys, now the thing is, okay, now my aim is what? My all five pieces will work together. Okay? Till this point, just stay like that and let me talk about hub. Okay? My aim is this. Okay? Now, if I define, I'm not talking about this now. Just forget about this now. We will come back to this. We will come back to this. So when if I want to define hub, so yes, as you most of you guys said that this is a dumb device. I just don't want to be rude with hub. So I'm saying it is non-intelligent device. Okay, not an. It is not an intelligent device. Okay, it works with bits, uses broadcast for communication. Okay, half duplex communication. If any one of you having any doubt with last 2 points, just note it down. We will come on to it after discussing all of this. So it is not an intelligent device for sure. You can call it dumb. Okay. It works with bits. Okay. And it uses broadcast for communication. Okay. And it is a half duplex communication. So these two
Sir,
terms.
hello, sir. Excuse me. Sir, can you repeat the hub? Repeat once again.
Yeah, sure. So as we have already stated in starting, this hub is a dumb device. Okay, so I am stated it not in that rude language. Okay, so it is not an intelligent device. Although it is dumb. Okay, so it is not an intelligent device. By mean to say that it is a device which will gives you connectivity. That's it. That we will talk in this example, and it works with bits. Just note it down. And the third point is it uses broadcast for communication. I highlighted the broadcast. And then the fourth point is half duplex communication. I highlighted half duplex because after the network devices thing, we're going to talk about broadcast and half duplexing. So till this point, guys, just remember this four term about hub because currently we are just talking about network devices. So one of them is hub. So for hub, it is non-intelligent devices. It works with bits. It use half duplex thing for communication and also use broadcast to communicate. Okay, till this point, let's come to switch now. Let's come to switch. You know about hub. Okay, you know about hub now, right? You know about everything about hub. It is a non-intelligent device, works on bits. It uses broadcast to communicate, half duplex communication. Okay, so let me just rub it. Now let's talk about switch. Now
Sorry, are
let's
you going to explain these points like it works with bits and you
I'll,
broadcast for communication?
I'll do that. That's why
Okay.
I marked them. We're gonna talk about that because why I'm doing that, you will got to know just after 15 minutes. As I
Okay.
stated, guys, we are here with bunch of people, and I know some of them, as I heard the terms from you guys, I know some of them do have understanding about networks, know about what is switch hub, but I do have some of the people who are pretty new, who they don't know about networking. So I'm just considering all the student as a hub. Okay, got my point? I'm not saying you guys dumb. I'm just saying. Okay, so for switch, wait a minute. Okay, so switch. So switch. When I talk about switch, so it is an intelligent device. First of all, maintains MAC address table, or you can say hardware address. Okay. Flooding and unicast. Mark those terms. Flooding, unicast. We're gonna talk about that right away. Support full duplex communication. So guys, now if I'm comparing hub with switch, as the difference I can see, first of all, hub is a not an intelligent device, but I'm calling switch as an intelligent device. Okay, hub work on bits, and I'm saying switch it maintains a MAC address table. Just forget about MAC. It maintaining a table where we can see hardware addresses, right? Just forget about MAC address. Don't If you don't know MAC address, just forget about this. Just relate this. Switch make a table where there is a hardware. I'll tell you what is that. Okay. Then the third point is works with flooding and unicast. Okay. Mark this word flooding and unicast. And after that, it support full duplex communication. Main aim for switch and hub. My main aim to connect 5 PCs. Right? I just want to connect my 5 PCs together in a network. And by that, I can see I can do both the things with hub and switch also. Right? Now, just take a break, guys. Just take a break from this network device and just take a break from this network device. Just keep in mind, we were discussing about switch and hub. Okay. Now come to types of communication. How many types of communication, guys, we have? Because we used some terms over here, which are unicast, which are broadcast. So what are those terms? So those terms comes under types of communication we have. Okay. So let's talk about unicast. Okay. Now, when we talk about unicast, so guys, unicast involves sending data packets from one sender to one specific receiver. It's basically one-to-one communication. PC1, PC2, PC3. Now I want to connect to PC1. I'm PC1. I just want to connect to PC3. I don't want to connect with PC2. So this intelligent device or this dumb device, whether it is, whoever it is, being a network administrator, I got this requirement. I need to connect each and every devices together. I have done that. But now, being a PC1, they just want to communicate to PC3 only. Because they just want to connect to PC3 only. So we need to have something, right? There should be some mechanism or there should be any type of communication by which we can or I can define that, okay, if you want to connect to this only, this is the type of communication you should have. So by saying in unicast, I am mentioning that it is sending data packets from one sender to one specific receiver, or it is one-to-one communication. Now you guys got to know how I can connect. Just forget about the intermediate device. Just forget about that. Now you guys know if I want to communicate with PC1 to PC3, I can use this type of communication. Unicast, right? Right, guys? Guys, is this right? Unicast, you got to know
Yes.
what is unicast?
Yeah, yeah.
One-to-one
Yes, yes.
communication. Okay. Now we have another term, which is multicast. So it involves what? Let me just write it down first. Sending data packets, sending data packets from one sender to multiple specific receiver. Okay.
So as you can see, the multicast is the same as the broadcast.
We will talk about broadcast. Just wait. So multicast is it involves sending data packets from one sender to multiple specific. Guys, mark this term specific because I am coming on to broadcast. Okay. Now just come to this figure now. Okay. Now I am PC1. PC3 is one of my friends. Now I have a friendship with PC2 also. And now I want, okay, first of all, I was using Unicast. Okay. So whatever I'm sending, please send it to PC3 only. Right. But now PC2 is my friend. Okay. Now I want, okay, we got some more people to join our organization. We have bunch of people now. This is PC4, this is PC5, okay? So now, out of 4 and 5, I want my data should also be go to PC2 also, or vice versa. I'm saying vice versa. Although we're going to talk about vice versa thing, but now I want, okay, first previously when I'm using Unicast, I can only communicate with PC1 to PC3. But now, okay, I want, you can send my data to PC2 also. So when I am sending data from one to many, but specific receiver. See, we have PC4 and PC5, but I don't want. Previously, I'm just doing one-to-one mapping, PC1 to PC3, but now I want my data should go to PC2 also. So now what I'm trying to do, the data from PC1 goes to PC2 also and PC3 also, but not for PC4 and PC5, because in multicast, guys, we send data to multiple persons, but specific receiver. I can mention my specific receiver. That okay, if I'm having 5 PCs, I only want my data to be traveled from 2 and 3 only, not for 4 and 5. Got my term, guys? Got my term? Unicast, multicast, any doubt?
No, all clear.
All clear?
Not
Okay. Now comes to another type of communication. Broadcast. So, guys, what broadcast meant, as the term stated, that broadcast communication involves sending data packets from one sender to all the device within the network. It is one to all communication method. I just forgot the name. Whosoever asks the difference between multicast and broadcast, I hope you got it now.
Yeah. I'm getting you. I asked.
Okay, Mohammed. Okay. So let me just write it down, then we're going to talk about broadcast communication involves sending data packets from one sender to all devices within the network. It is one to all communication. Okay, so now let's come to the scenario again. Now I have a scenario where I am being promoted as a lead. PC1 is me and I'm a lead. And I want, so guys, this is a hypothetical scenario, right? Don't try to relate that. I'm just trying to say what is broadcast, multicast, unicast, okay? So now PC1 wants everything that I send, everything, whether it is rule, whether it is mail or anything, it will go to each and every one of my company. So in this example, I'm having PC1, PC2, PC3, PC4, and PC5. PC1 is lead now. So he or she wants, if I'm sending something, that should be go to each one of them. Each one of them means every device that is connected in my network will be receiving anything that I'm sending from PC1. So that comes under broadcast. Guys, unicast, multicast, broadcast. Any doubt? Any one of you?
No, sir.
Got the point, guys?
Yes, sir.
Yes, sir.
Okay, great. Okay, so now let me just rub it. You guys know types of communication, guys. Okay, let me just comes to now mode of communication. Okay, we heard about unicast, multicast, broadcast. Now let's talk about mode. How this data will that data packet will flow, right? Let me just rub it real quick. I'll make new one. Okay, so now let's go to modes. Modes of communication. So first we have simplex, half duplex, full duplex. So guys, if I talk about simplex, so in simplex, data travels in one direction from sender to receiver. So what happens is data will only travel from only in one direction. So the receiver cannot send data back to sender in a simplex mode. Let's again come to an example. So if I'll go for simplex from here, okay. So now if I'll go like in a mode of communication is simplex only. So if I'm sending data from PC1 to PC5, okay. So as I stated in simplex, guys, this is only one-way communication. One-way communication. If I'm sending anything to PC5, PC5 won't be responding me because in here we only have one direction. So if I can give you a simple example of it, guys, it is we are watching TV station broadcast, right? We have a radio, right? We are watching TV. If the thing that comes on TV, we are not able to, say anything to them. This is one way call. Whatever I'm saying, you're not say or you're not able to answer that. You're just seeing. You're watching TV. That is the simplest because you're not saying you're not interacting with it. You're just watching it. There is only one way communication. The receiver cannot send back data to sender. Guys, got my term, the simplex? One way communication.
Yes, sir. We got it.
You got it.
Everybody? Okay, great. One way communication. Okay, guys, any doubt, anything for half duplex? Because from simplex, you must have an idea, right?
I'm a half duplex. Let
Mhm.
me say it's also one-way communication, but at a time. It goes two-way communication, but it goes one at a time.
Okay, got it,
It
got
can't
it.
send both at the same time.
Okay, anyone of you can say?
Walkie-talkie is an example for the half duplex.
Yes,
One
it is.
can.
Yes, it is. Half. So, guys, half duplex is what? Half duplex. In half duplex, data can travel in both directions, but simultaneously. But simultaneously is a point where we need to give more pressure to learn that. See, in simplex, there is only one-way communication. But in half duplex, we have two-way communication. But if I'm speaking, you won't speak. You can just there to wait once I'm finished. So if I'm sending any data to you, once you receive that, then only you can send back it to me. So as Nikun said, walkie-talkie. You hold or you press the button to talk. When you receiving anything, you won't be able to talk, because if you do so, there will be lack of communication. There will be a collision of data. Right? Guys, any other example you want for half duplex, or is it fine?
It's fine, sir.
Okay. So let me just write it down the main term. Data can travel in both directions. Not simultaneously. Okay, so you have to wait. It alternates between sending and receiving. Once you are sending something, you won't able to receive anything. But whenever you are receiving something, at the same time, you won't able to send it. Right, guys? Now come to the final one, which is full duplex. Any one of you?
The full duplex data can travel in both directions simultaneously.
Yes. Allow data to travel in both directions, similar to half duplex, but simultaneously is the word. Right, guys? So from here, you and me currently talking via Zoom. This is what way of communication, guys? What was this mode? Tell me.
Full duplex.
Full duplex. Okay. Any one of you? What is the mode?
I think it's half duplex, isn't it?
Okay. Any one of you can add something to this?
So it's a full duplex, sir.
Okay. I want one more vote. One more vote. Come on, guys. Any one of you? Half or full
duplex.
or like is it full?
Full duplex, sir.
Okay. Okay. So Nasir, you said half duplex, right?
Yes.
Okay. So Nasir, well, the answer is full duplex. Why?
Okay.
Because I'm saying something, and in between you said something, right? And
Yes.
I received that data, right? I
Okay.
am saying something, you hearing that, at the same time you answering me, right?
Yes, true.
Okay.
When I paused it, so I thought maybe it's half duplex.
So
You know, I got it.
see, I can make this half complex by going to setting and mention that all participants won't able to unmute. I can
In that sense, okay.
in that sense it is half duplex, but currently it is full duplex. Got my
Yeah.
Yes, sir.
so guys, I have this power to make this half complex. Like, but full duplex is always comes under so that both parties can talk and listen. Talk and listen, right? Okay, guys. So now mode and type of communication is done. Done, guys. Any doubt in types of communication and in modes of communication?
No, sir.
Guys, please confirm each and every one.
All
No,
clear.
sir.
Yep.
No doubt.
No doubt, sir.
Great,
No doubt.
great. Okay.
No doubt.
Sir,
Okay.
can you example for the simplex, half duplex, full duplex? That one, sir. Example.
Okay, so you want example.
Yes, sir.
So in Simplex, the simple example, you're watching TV, you're watching YouTube videos. That the traffic is flowing from only one side, right? You can only watch.
Yes.
And
Simplex.
for yes, for half duplex, you can go for walkie-talkie. You need to press button when you want to speak, and when you just release the button, you can listen what the particular person is saying to you.
Okay. Walkie-talkie, that one, half duplex.
Yes, and for full duplex, you can refer to our Zoom meeting. Or
Which one?
for full duplex, you can go for in a real time. It's a phone call.
Phone call. Oh, yes. Okay. Okay, sir. Sure.
Okay, guys.
In example router and switches, which one out of that one example mode communication?
Sorry, what you say?
That one is a switch or hub router is there, sir. Example. Okay. That one, which mode communication they are working now?
I'm coming on that point. I'm coming on that point.
Yes, yes, sure.
So you can see hub and switch now, guys. Okay, hub and switch. Now the term on hub that I marked is uses broadcast for communication. Is that clear now?
Yes, sir. Yes, sir. Yes,
And
clear.
for half duplex communication, is that clear now?
Yes.
Yes, sir, clear.
And when we comes to switch, switch works on unicast and flooding. Forget about flooding. Unicast, is that clear now?
Yes, sir.
One sender to one specific receiver. And supports full duplex communication. Is that clear now?
Yes.
Yes,
Okay.
clear, sir. Clear.
Okay. Now just again comes. So guys, now any one of you can volunteer and try to explain why we call hub as a dumb guy and switch as an intelligent guy. Come on, just a layman language. Don't use any technical terms. Just a layman language.
Sir, hub don't maintain the table, sir. MAC address table like that. Hub don't maintains. The switch can maintain, sir. So it can reduce the time. So that it can send a specific system. Whatever the data need, switch can directly send to that system. But hub every time it do broadcasting, then only finds and shares the data.
Okay. Pretty enough. That is great. Another one. Any one of you just again go for it. Tell me you have all the four features marking on hub and switches. Now you just need to say why are you calling hub a dumb guy and why you call switch as an intelligent guy. Come on. Any one of you go ahead.
So Arun, let's say if there is a hub in between and five PCs are connected to it, and PC1 wants to talk to PC2 in the network. And when we are saying that it uses broadcast for the communication, so that means if PC1 wants to talk to PC2, so it will send the packet to all the devices which is connected to it. And this is the kind of intelligence that it is missing in the hub to route, or you can say to send the packet to a specific or to a specific users which is destined to. Now, when it comes to the switches, as we mentioned that it supports a unicast mode of the communication, and in it, let's say if PC1 wants to talk to PC2, so it will not send that packet to all the connecting devices. It will just send the packet to that specific users for which this packet is destined.
Okay.
Yeah.
Any one of you, any one more people just come and volunteer to explain all these points. Mohammed, Nasir, any one of you?
Um, just for the hub, I think it's a half duplex and switch is a full duplex. But again, in the future, we'll come to know that, switch is also act in a way half duplex, but there is, what you say in a Cisco packet tracer. So we have settings that we can maintain according to the speed to make them enabled
Okay.
in a full duplex. Yep.
So the thing is, yes, we can do that, but there is one catch. In Hub, it's mentioned that it uses broadcast for communication. And for switches, it's seeing that works with flooding and unicast. But what if I tell you guys, switch also do broadcast? How many of you agree with me on that? What if
Yes,
I say that?
I agree, sir.
I agree.
Don't give explanation. Don't give explanation. Don't give explanation. You agree with me that, right?
Agree, sir.
Okay, guys. Now let's come to the main point. See, there is one fact. We always prefer switch over hub, right? We always prefer switch over hub. But why we do so? So any one of you can say why we do so? Any one reason, one liner. Don't go for the explanation. One liner.
That's intelligent.
It is intelligent. Okay. Any one of you, just give me one word, one liner. Why you prefer switch over hub?
Which is intelligent, sir.
Okay, it is intelligent. Okay, switch intelligent guy. Okay.
Because of switch any connectivity that one providing, sir, data sending and receiving that one.
Okay. So guys, all of you declared that hub is a dumb guy. We prefer switch over hub. But you guys are right. You guys are right. Let me explain why. So are you up with me on that, or should we do that tomorrow? What do you say?
I would like to you can finish this off, so it will be kind of good.
I don't want you guys to stay in suspense till tomorrow, right?
Yeah.
Okay, guys, let's do it. It's a really important thing. Why do we prefer switch over hub? Let's do it. Wait, this does not look like a good thing. I'm just creating a simple network. All the way two network at a time. This is hub. This is switch. Okay. These are PC1, PC2, PC3, PC4, PC5, PC1, PC2, PC3, PC4, PC5, PC6. Now, guys, as we have already talked about mode and types of communication, if we use hub now, we can see that it works under broadcasting. Okay, it works under broadcast. So whenever, if I want to communicate with PC5 only, let me use which color. Okay. So if I want to communicate with PC5, let me send the data. That data comes under hub. And what we have learned that hub will do the broadcast. So broadcast, what we have learned in broadcast, guys. Come up with the reply. What we have learned with the broadcast. It will do what? Come on.
Sends
Sends
packets to
packet
all the
everywhere.
one.
So now suppose PC1 sending hello to PC5. So now, as just forget about intelligent or dumb, okay? We have a characteristic which is hub will do broadcast. Okay. So now my message is for PC5, but what this dumb guy did, it will send hello to all. Hello, hello, hello message, hello, 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 hello message to all the five PCs, all the four PCs. He's not doing something wrong because we know that. We know that Hub will do the broadcast thing only. So he's doing what he meant to be. Hub is made to doing only broadcasting. So Hub once get any message, that particular device will send that message to all of the nodes present onto that device. On Hub, if we have all the way, nowadays we don't have more than eight ports on Hub. But previously it was four, but now in some of the hubs we will get the eight ports. But if we have hub in my network, it will give each and every time I'm sending message to any of the PCs that connected in my network, it will send those data to all the PCs. Okay, but I don't want, if I am sending a data specifically to PC5, I don't want that data should be broadcast to each of the member that is connected to my hub. By that, what happened? What happened, guys? If broadcast is happening, what happened? Don't you think the processor, everything that is, I'm not going into technical term, but don't you know the processor getting too much load, right? Don't you think it will get too much load? And one more thing, okay, broadcast is okay, but what it will do in half duplex thing? In half duplex, when I'm sending to PC5, PC5 won't able to send it me back simultaneously. PC5 needs to wait. Once I'm sending hello message to PC5 and hub will do the broadcasting, it will do the broadcast. Everybody got this hello. Okay. Now PC5 needs to wait. Once PC5 receive my hello, then PC5 will send it back to PC1. But now in this reverse path, what happened again, guys?
Will
What
sends
happened?
the response to all the one.
Any one of you guys, you understand? Once PC1 send hello to PC5, at that time hub broadcast the message hello, hello, hello. Okay, now everybody got the hello, but PC5 will be replying PC1 with the hello, hello, hello. But now this dumb device again send it to all the connecting peers like hello, 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 all. So don't you think this is a right way to get communication done? What do you think, guys? Is this a right way?
No. In other words, hub is using extra resources and plus there is no security.
Yes, everybody will seeing what exactly happening in our network. Done, guys, done. You got to know about hub. Anybody raising hand? I just
Got it, sir.
That was me. Yeah.
okay. So guys, got to know about hub. Everything is clear with respect to hub.
Yes, sir.
Okay. Now here we go for switch. Okay. Now we have replaced that dumb device by an intelligent device, as you guys said, with switch. So now,
Arun, I do have a question here.
yes,
So the first question is, let's say PC1, the initial conversation which PC1 is sending to the PC5 hello. So do hub will send back the hello back to PC1 also, or it will just focus on PC2, 3, 4, and 5?
so you saying with respect to hub.
Yeah, I'm saying with respect to hub. Let's say PC1 sends hello to PC5. Now
Uh-huh.
hub is doing broadcast to PC2, 3, 4, and 5. So will the hub sends back the hello to PC1 also in response as a part of the broadcast?
So for that, no, it
Okay.
won't send PC1 that hello because see, okay, the broadcasting is okay, but if you remember, it goes with respect to half duplex. Sender won't receive at the same time once the message got sent, half duplex.
Okay. Okay.
Got the
Okay.
point?
Yeah.
Uh,
One last question I'm having. Like, let's say in the same conversation, PC1 wants to send anything to the PC5, and in between PC4 wants to talk to PC3.
uh-huh.
So there involves too much of congestion in the network, or like how this flow will happen. Like,
The thing,
do
okay, the thing is in that scenario, there is one term in networking. The term that refers is collision. Data
okay,
collision will happen. Okay,
okay,
because
okay,
we are trying to communicate, PC1 trying to communicate with PC5, but in between, PC2 wants to communicate with PC3. But when hub got all the information, it will got collide with each other, right?
okay, okay,
So by this, network will hang up, network will be held slow, your processor will be using much more all the resources. So collision is another different term. We're going to talk about that.
yeah.
Okay, so now any doubt with respect to hub now, guys? Because I don't want to stretch the things. Just quickly come on to switch. But before that, any doubt on to hub?
No doubt.
Okay.
No, sir.
Okay, guys. Now let's come to switch. Now we replace hub towards switch. And now again my PC1 trying to communicate with PC5. Okay. Now let me just make this. Okay. So now PC1 again send hello to PC5. And what if I tell you once switch re- receive that hello? Don't yell on me, guys. Now I'm again saying switch will also broadcast this. Similarly, like hub, switch will also broadcast this hello message. Got the point, guys? Switch will also broadcast this message. Right? Right, guys? Right? Any doubt in that? Okay.
But when this switch acts in a way, asks, okay, sends a query that I'm trying to communicate with the PC5, can the PC5 please reply me back? So in that sense, he sends the hello message.
Yes, you're saying what I'm supposed to say after this. I was supposed to say. I just
Ah,
say
okay, my bad. Sorry.
no issue. So I'm just saying the fact. See why I'm saying broadcasting, because I have written that it works with flooding and unicast. So that's why I'm saying don't ever say hub is the one who broadcasts, switch won't. Switch also do the broadcasting, but just refer to point number 4 for hub and switch. You will got the difference. For hub, it works on half duplex, but for switch, it works on full duplex. Full duplex means while the time you listen, you can answer too. So when this message got broadcast by switch, PC5 would immediately reply, that is for me. Once this initial thing happened, once this initial thing happened, PC5 replied to hello, switch got to know, okay, this packet, this hello is for only PC5. So after broadcast, after that, or you can say after flooding, this thing gonna happen. Okay, is that making sense? How unicast comes in a role? Once the broadcast is done, PC5 replied, because they are working in full duplex condition, they can straight away reply. Now switch knows this hello packet is from PC1 and goes only to PC5. By that, it will give them unicast condition. And we have learned that unicast is one to one Communication. Okay, guys. Okay, guys. Just got to know about this term and tell me where are you on this term. I'm not jumping into another factor. I need to discuss that one point also. How Switch gonna do it? But before that, just tell me, are you able to understand why full duplex, how unicast, first broadcast, full duplex, then switch over to no unicast? Now tell me. Guys, come on, at least say yes, no, sir, I'm confused, sir, I didn't get anything. At least say something.
I think I'm clear with that. Whatever explanation you have given, I understood 100%. Yep.
But there is one more point. There is one more point that we need to discuss. How it works in unicast after that. But guys, if you all are okay with it, then I'll raise to that. Just tell me, are you okay with that? Broadcast,
Yes.
full duplex,
Yes, sir.
unicast.
Yes, sir.
Unicast is one-to-one.
Mhm.
Multicast is one-to-many. Broadcast is one-to all.
All the users, yes. So
So,
first,
Arun,
yeah.
I do have a question here. In
Mhm.
the switch side, let's say PC1 wants to talk to PC5
Mhm.
and it sends an initial message. The
Mhm.
very first communication is happening now between PC1 and PC5.
Mhm.
So, let's say the first time when they're communicating, I am expecting that the switch will do the broadcast.
Mhm. Yeah.
And every consecutive chat, let's say after the initial conversation has been happened, now PC6 wants to send something to the PC2.
Mhm.
So at this point of time, I am expecting that since this is an initial conversation, they will switch will do the broadcast. But once the communication has been set up, so after the next consecutive communication happens between PC1 and PC5, so it switch will send the broadcast to everyone and then wait for the unicast, like, or it is something that once the inventory has been built, then it will kind of a process. It will kind of a do only the unicast.
Okay, so the thing is, initially, for the very first time means very first time, this switch just got installed in the network, and
Mhm.
after that, PC1 tries to communicate with PC5, and it will do the broadcasting. And as we are working in full duplex mode, every PC replied, and out of that PC5 replied, that packet is for me. Communication happened, done. Now, after that initial packet, unicast will happen. How unicast will happen, I'll come on to that point. Just wait. How these things happen. But for the question you asked, I just answered that afterward because for that one major term is there. If you can just read the second point, which is it maintains MAC table. We will come on to that point, but first I want from you guys to confirm you don't have any doubt with initial broadcast, after that full duplex, after that unicast. So just confirm me that are you guys clear on that?
100%.
Clear, sir.
Yes, sir. Clear.
Clear, sir, clear.
Okay, guys, now the question, now you should have questioned me, sir. Okay, we understand the point broadcast, we understand the point full duplex. Now, how come it make unicast? What is unicast, guys? Any one of you just unmute yourself and say what is unicast?
One-to-one because obviously in the future you will explain it to us. There is ARP resolution, address resolution.
Just
Yep.
set 1 to 1. Don't go further. Don't go further.
Yes, one-to-one. So it in the beginning, it works as a, my bad. It works as a broadcast, but in the future it works as a one-to-one.
Yes. Okay. So, guys, any doubt? Like now, the question is how unicast. Now, how Switch knows after initially broadcast all the packet, what will happen to Switch? Now he knows that this PC is for PC5 only. How PC knows? How this Switch knows that? That is the reason. How Switch knows that this is unicast now? How? What was the mechanism? So, guys,
Address
The
resolution
MAC
protocol.
table to the MAC table.
Exactly. Just forget about the Mac. Mac is nothing. Initially, we don't talk about Mac. Just initially,
Using port
hardware,
number, sir.
hardware address. Sorry.
Using port number.
No port. No, not a port number. I just come on to that. So just mark this term, which is hardware address. So now the forget about MAC address, just forget about something. What initially happened in a simple language, just mark my this term, forget about MAC address, forget about hardware address. Nothing like that. Just all the people who don't know about anything, just listen to me carefully. Now what happened? Switch will broadcast the message, and in this reply section, see these machines, the endpoints machine. They have something. I'm saying something. Just mention that something, a value. All these machines have some unique value with themselves. PC2 have their unique value. PC1 have his own unique value. Unique means all the values of all the PCs are different. Suppose PC1 have AA as a unique value, PC2 as a BB, PC4 as DD. These all are the unique value that all the PCs are holding. So now, why we are calling switch as intelligent? Because initially, when switch broadcast the message of PC1, hello, switch will switch is an intelligent guy. Switch don't want to work like donkey. Switch is intelligent guy. Switch knows, okay, they installed me in the network. Now what they want? They want me to do the work. So how can I minimize my work? But on the place of switch, hub is something, okay, give me the message, I'll send it to each one of them. Whosoever is, reply me back. But for switch, what switch is? Switch is something, okay. Switch making a database in a memory, in his memory, that okay, let me do an intelligent work. That intelligent work is what? All the endpoints, all the pieces connected to me, switch knows they all have some unique value. So switch makes a table. Okay, these all 5 PCs are connected to me. Okay, and as I mentioned, all the PCs have the unique value. Unique value means they all are different from each other. So PC1 have the unique value of AA. So how switch is intelligent? Switch will mark this value. Okay, for PC1, the unique value is AA, PC2, it's CC, PC4, it is DD, PC5, it is EE, PC6, it is FF. Okay, now switch maintain this database. Switch is a clever guy. He stored this thing. Okay, PC1 having the unique value AA. So now when PC1 again or when PC5 replied, see, when this hello comes to switch, every one of them is replying. Once they reply, in that reply, PC5 mentioning, okay, this packet is for me. But all these PCs, 2, 3, 4, and 6 are denying, okay, this packet is not for me. But in that packet, how PC2 identified himself on switch? He will send this packet is not for me with his unique value. So that switch knows, okay, this decline message is from PC2, right? So after that, switch will maintain a database. In that database, he will store all the unique value. Okay, all the unique value. Once they are done with that, now switch have all the unique values of PC. So whenever now onward, after this broadcast, once this broadcast is done, switch got to know about all the values. Okay, now switch is ready. Switch is like, okay, bring on all the messages, all the data, bring on. I'll know from whom I got the message and from to whom I need to send it, right? And how switch knows that? Because switch store a database of those unique values those all the PCs have. So now, how unicast has happened? Unicast happened because Switch is a smart guy. Switch now stores a database in it, and in that database, Switch knows what are the unique values of all the PCs. So now, after initial broadcast, when any PC wants to communicate to any other PC, unicast will happen. Why unicast is happening, guys? Because of this smart database that has been stored by Switch. I am done with this. Now, you guys bring on all the questions. But just just got to know that how unicast is happening after broadcast, the reason behind. Just forget about this MAC address table, just forget about this hardware table, just concentrate on what I'm saying. We have a unique value for all the PCs, and Switch will maintain a database where it store all the unique values of all the PCs. So now onwards, when PCs trying to communicate with each other, with that message they take their unique value also. And once Switch knows, okay, the message is coming from PC1, and in that packet PC1 mentioned that I want to communicate with PC5. So now Switch knows the path, or Switch knows where PC5 is there. Okay, he sent that message straight to PC5, from PC1 to PC5. That's it, guys. Bring on your doubts.
So Arun, I do have a question here.
Sure.
So do Switch wait for the initial conversations to happen to build the MAC table, or do Switch build the MAC table during the configuration itself?
No. So initially, why initially broadcast happen? This is why Switch broadcast, because whenever Switch broadcast, all the connected PC will come up with some reply, and in that reply, they take a message. This PC, this packet is not for me, with their MAC address or with that unique value. Sorry for MAC address, with that unique value. So now Switch was like, okay, thank you, and it stored that unique value in the database.
Okay.
So after initial broadcast, that is the reason why I said, why don't you ask me how after broadcast continuously you said unicast is happening? Because of this smart database, unicast is happening. Guys, any doubt? Come on, just respond to it. It's a important topic to understand why nowadays we are replacing switch from hub. Sorry, hub from switch.
Sir, I have one doubt, sir.
Yeah.
If in switch have already gathered the MAC table, after that one system is connected, then on which frequently it will get the MAC, create the MAC table, sir.
I didn't understand your question. Just repeat it one more time.
Sir, now the switch have PC until PC5. So it created, it has done broadcast and it created MAC table. After that, we are connecting one more system to that switch. On which frequent it will create again the MAC table. It will correct the MAC table.
Oh, so once you introduce one more PC to it,
Yes, sir.
Once see, as I said, whenever you sending a message to, suppose PC1, now try to let me make. Now just we have one more PC. This is PC7, right? Now PC1 wants to communicate with PC7, right? So PC1, in that packet, PC1 take his MAC address, or suppose that value and the message, right? And it goes to switch. And now switch check his database. And he's checking that, okay, I got something new. This unique value, suppose for that we have ZZ unique value of PC7. Now switch is like, okay, ZZ is not connected to me. Is it? So now switch again do the broadcast to get the MAC address of. So once it's again do the broadcast, they all are again send it. This packet is not for me and their unique value. Like that, switch will got to know about PC7 now. Okay, ZZ. Okay, let me maintain your value. After this initial broadcast, again unicast will happen. This happens again and again until unless all the ports are blocked
India.
or all the PC or all the ports are connected to another PC.
Class.
You got it?
Sir, yes, sir.
Is that clear, Dave?
Yes, sir. That's clear, sir. If the system is connected with one, okay, sir. The switching concept I clear, sir.
We will be spending much more time on switching, guys. This is just the initial phase. Okay, now, guys, if you guys don't have any doubt, let's wrap up for today and we'll meet tomorrow at the same time.
Wow.
And guys, one more thing, like we updated a new Zoom ID in the portal. So for tomorrow's session, please follow the same.
Sorry, what was the ask?
I said that we changed the Zoom ID for tomorrow's session. So whatever is updated in the portal, please make sure you'll join according to that.
Okay, guys, understood. So the meeting invite has been changed now. So you will be getting all the meeting invites on the portal. So you do join by that meeting invite only for tomorrow, from tomorrow onwards. Okay. Okay, guys. If everyone is okay, let's wrap up. We'll meet tomorrow with some new